On the night of April 14, 1912, the RMS Titanic, the most advanced and technologically sophisticated feat of naval engineering of its time, was cutting through the icy waters of the North Atlantic on its way to New York, when it violently collided with a massive iceberg. With more than 2,200 people on board, including passengers and crew, the tragic sinking of the Titanic ultimately caused the deaths of 1,496 people. To completely understand how this terrible shipwreck occurred, we conducted an in-depth technical analysis to examine how the impact with the iceberg took place, and determine the sequence of events that ultimately led to the sinking of the Titanic. On April 10, 1912, the RMS Titanic departed from Southampton bound for New York City. At the time, it was the largest and most luxurious ocean liner ever built, measuring roughly 882 feet in length, 95 feet in beam, and displacing over 52,000 tons of water. Its propulsion combined steam engines and a Parsons turbine, capable of generating nearly 46,000 horsepower, driving 3 propellers that allowed it to reach cruising speeds of 21 knots, about 25 miles per hour. The Titanic structure was divided into 16 watertight compartments, separated by 15 transverse bulkheads that could close automatically in an emergency. In theory, the design allowed the ship to remain afloat even if up to 4 compartments were flooded, and it carried 20 lifeboats with a total capacity of around 1,178 people, insufficient for everyone aboard, but compliant with regulations of the time, which were based on the ship's tonnage rather than the number of passengers. With this combination of size, powerful engines, and compartmentalization, the Titanic was considered virtually unsinkable, a testament to early 20th century technological ambition. On the night of April 14, 1912, the Titanic was sailing at 22.5 knots, a dangerously high speed given ice warnings received by radio from other ships navigating the same stretch of the North Atlantic. Conditions were especially challenging. There was no moon, and the sea was surprisingly calm, preventing the formation of foam around icebergs, a visual cue that normally helps to detect them. Under these circumstances, the lookout's ability to spot obstacles was severely limited, and the fact that they lacked binoculars made matters worse. At 11:40 p.m., Frederick Fleet, the lookout in the crow's nest, spotted an iceberg less than 1,640 feet away, and quickly sounded the alarm to the bridge. First Officer Murdoch ordered a turn to port and a full stop in reverse, maneuvers that, due to the massive liner's great inertia, proved insufficient to avoid contact. The Titanic struck the iceberg with its starboard side, scraping along roughly 295 to 328 feet of the hull, mostly below the waterline. From a structural standpoint, the contact did not create one large continuous breach, but instead produced a series of linear deformations in the steel hull plates, which resulted in the progressive failure of the rivets that held those plates together. Many of these rivets were made from low-quality iron containing inclusions or slag residue, causing their structural strength to become extremely brittle in the freezing temperatures of the North Atlantic, at around 28 degrees Fahrenheit or thereabouts in winter. Under the pressure of the ice, the rivets either fractured or came loose, releasing the junction points between the plates and allowing water to penetrate the forward compartments. This was compounded by the behavior of the hull's steel, which at temperatures close to the freezing point underwent a significant ductile transition, losing its ability to deform and absorbing less energy at the moment of impact. The combination of fragile rivets and brittle steel proved decisive, as water began seeping rapidly into the watertight compartments, thereby initiating the ship's progressive loss of buoyancy. Following the localized failure of both the hull steel and the riveted joints, the flooding process followed what engineers now refer to as progressive propagation. The first 5 forward compartments began filling with water. The pressure and weight of the liquid caused the bow to sink gradually, increasing the vessel's trim and allowing water to spill over bulkheads that did not extend up to the upper deck. Water then began cascading from one compartment to another, as if the compartments were linked in series, accelerating the loss of stability. Each flooded compartment increased the structural stress on the joints between plates and rivets, amplifying the hull's deformation. This phenomenon, known as the flooding domino effect, explains why the Titanic did not remain afloat even though its design could tolerate up to 4 flooded compartments. As the forward compartments filled, the bow continued to sink and the list further steadily increased, generating extraordinary forces on the hull, which began flexing beyond its elastic limit. At 2:18 a.m., the strain reached a critical point as the ship's midsection, significantly weakened by the accumulation of water in the bow and the structural resistance of the stern, failed structurally, causing the Titanic to break into two sections near the third funnel. The stern section, still partially afloat but already severely weakened, remained above water for several minutes before sinking completely at 2:20 a.m., completing the tragic disaster. The mechanics of the sinking reveal a complex interaction between materials, structural design, and external forces. Meanwhile, the iceberg, approximately 328 feet long and rising about 65 feet above the water, with an estimated mass of about 220,000 tons, exerted considerable forces on the Titanic's hull, whose displacement was around 50,700 tons, contributing to the failure of the riveted joints and the onset of flooding. The collision did not need to directly puncture the steel. The failure of the rivets and the propagation of cracks along the plates was sufficient to allow water ingress. The calm sea and lack of moonlight contributed to the late visual detection of the iceberg, while the absence of binoculars for the lookouts further reduced the available reaction time. As the bow sank, the crew began the evacuation at 12:05 a.m. Orders were given to prepare the lifeboats and gather all passengers, yet the operation turned out to be extremely chaotic and very inefficient. The shortage of lifeboats, the disbelief of many passengers, and the crew's lack of proper training caused several boats to launch with fewer than half of their full capacity. Some boats, like Boat Number 1, left with barely 12 people on board when they could have carried as many as 40. The application of boarding priorities was inconsistent. First Officer William McMaster Murdoch, stationed on the starboard side, allowed men to board if no women were waiting, while Second Officer Charles Herbert Lightoller, positioned on the port side, strictly enforced the rule of women and children only, causing significant differences in the number of people on each boat. Most of the victims did not die by drowning but from hypothermia. The water temperature, just below 28 degrees Fahrenheit, caused the human body to lose heat extremely fast, producing severe cooling of the body within just a few minutes. Average survival time under these conditions ranges from 20 to 30 minutes, which combined with the extreme cold and the shortage of lifeboats, turned the Titanic's night into an immense tragedy. The massive collision with the iceberg, the progressive failure of the watertight compartments, and the rapid loss of structural stability demonstrated that even the most advanced ship designs of that time had limitations when confronted with extreme natural forces. The Marconi radio system aboard, although advanced for its era, played an indirect role in the tragedy, as it was overwhelmed with private messages, and the operators deprioritized ice warnings from other ships navigating through that area of the North Atlantic. Meanwhile, the operator of the SS Californian, located only 20 miles away, had turned off his communication system earlier, and if it had remained active, he could have assisted in the rescue operation. Finally, the Titanic sent distress signals using both CQD and SOS, and the Carpathia received the alert at around 12:30 a.m., arriving at the scene at 4 a.m. to rescue between 705 and 712 survivors. After the tragedy, naval engineering and international regulations were changed forever. All ships were required to carry enough lifeboats for every passenger, radio communication and lookout systems were improved, and the SALAS Convention was also created, establishing international safety standards for maritime navigation universally. The sinking of the Titanic remains a lesson in engineering and physics, as well as in material science and human decision-making, showing how even the greatest technological achievements can fail when faced with a combination of factors that go beyond any prior expectation undeniably. And with this, we conclude today's video. If you enjoy this type of content, I would really appreciate it if you subscribed and left a like, because thanks to your support I can continue creating more analyses and reconstructions like this one, and you'll also stay up to date with everything new we upload to the channel. Finally, before signing off, I'd love to hear your thoughts in the comments and know whether you think the Titanic tragedy could have been avoided in hindsight. Thank you very much for watching. I'll be reading your comments, and I'll see you in the next video.